So we're going to look at the control and operation of a propeller on a fixed shaft turboprop today. And so our two main things, just like the other turboprops we talked about, two primary modes of operation. We're going to have our alpha mode and our beta mode. And alpha mode is your, alpha mode is your higher RPM mode. It's used in flight. Okay, it's typically somewhere from a little bit above flight idle all the way up to max RPM. And then our beta mode is for our lower RPM areas, where it's for ground operation, starting, taxiing, and reversing. And here you can see that's from about 65 to 95% of RPM. Alpha mode's in that 95 to 100% of RPM. And when the airplane's in flight, that propeller is going to be running in that 95 to 100% RPM most of the time. That is the full range. Oftentimes, that 5 to 7% is the full range of flight RPMs. Anything below that is used for ground operation. And then there's nothing below about 65 RPM, and that's because the engine ground low idle speed is 65 RPM. It's rare that the propeller is going to spin slower than that unless the engine's in the process of starting up or shutting down. And so those really aren't a mode of propeller control. Okay. And this, again, it's not much different than what you saw on a free power turbine. What's different though is what kind of controls you have and how they operate the propeller in these different modes. So we'll start off with during the engine start. Here's our we kind of have two sets of levers. Remember, we don't have that third, we don't have a propeller lever. We have essentially a condition lever and a power lever on a fixed shaft turboprop because we aren't adjusting the propeller speed separate from the engine speed, right? The engine core, the prop gearbox, the propeller, they're all linked together in a fixed shaft turboprop. The reason you have the third lever in a free power turbine is because the propeller and prop gearbox in the power turbine can spin at a different speed than the core of the engine, the gas generator, and thus you add that third lever to be able to control the RPMs of those two sections separately. Okay. So here they're all the same, they're all linked together, so we don't need a third lever. We can control the RPM and the power using two levers. So during starting, here, let's look at the range. You've got power, you've got a power range on the power lever. There's a ground idle position. You move it up to flight idle, up to max power. That's where it's going to operate in the air. And then you've got a reversing position for use during landing. So for starting, we're going to have it in the start and ground idle position. Okay. The condition lever, there's a fuel cutoff back here. It's emergency and shutoff. In this case, the fuel shutoff is integral with the condition lever. There are some aircraft where the fuel shutoff is a separate little handle type lever, but in this case, this is what you see with an integral setup. The levers are moved to the start and taxi position here. The third position, takeoff, climb, landing, cruise, that's the higher power position. We're going to be in our low power position for the condition lever, lower RPM. And during the engine start, we start the engine, but after the engine's up and running, one of the things we have to do is those start locks on the propeller that prevent it from going to feather at shutdown, they're going to remain engaged. Even though the propeller starts up, remember those start locks are spring-loaded into the locked position. They can only move to the unlocked position through centrifugal force. However, when the prop first starts, they're in, and the start locks on the blades are engaging them. And so they won't be able to move out, they won't be able to slide out into the open position until we remove the blade, the force that the blade puts on the side of them until we back that away. And so in order to do that, the power lever action is eased towards the reverse position a little bit after the engine is started. And so the blades go to a very fine or a zero pitch position, which disengages the hooks from the start locks. Centrifugal force then is able to pull the start lock up and out of the way. And now we can bring our lever forward again. We can bring our start lever forward. And now that, because those pins are held up out of the way, now that blade can go past that and go towards that feather or that higher pitch position. So prop moves to the zero blade angle. That releases the centrifugal locks. They snap out. They move outboard away from the hooks. And then now you can move as long as the RPM stay above whatever speed it takes to get those start locks to move out or out of the engaging position. Then we can start to move our power lever, keeping our condition lever in the start and taxi position on the ground. And we're not going to bump the engine up to high RPM until we're ready to take off. Okay. So on the ground in a fixed shaft turboprop, when we're in the beta range, our condition lever is going to be to set the RPM, right? So here I said it goes in the start and taxi position. That's going to set our RPM into the lower range of RPMs. Okay? The power lever now is primarily, it's going to set the direction, whether we go forward or reverse, but it's primarily going to vary the blade angle. And it's going to do that by varying the blade angle. So it's going to be, our engine's going to be at a low, relatively low RPM setting. And that engine at a relatively low RPM setting, we can then start to push our lever forward to go forward, we can pull back to go back. And what's going to happen is we've set our RPM using the condition lever. As we start to push the lever forward, okay, we begin to lever it forward, this is when the pitch control mechanism, propeller pitch control mechanism is working, rather than the governor. Remember, in this case, the prop governor is separate from the pitch control mechanism. So the power lever is connected to this input that drives the follower sleeve. And so if we move the follower sleeve forward, you'll oil here, the governor, the prop governor is in an underspeed condition. So it's just going to allow the high pressure oil to flow out of it, to flow through the feathering valve, which is not in the feather position. And then essentially oil just passes through the propeller governor control, passes through the feathering valve, and now all the control is done using the follower sleeve and that beta tube. And so as we move it into various positions, we're going to change the position of the beta tube, and that's going to port or relieve oil pressure going to the piston, the dome at the end of the propeller in this case. So in order to do that, when we move it forward, it is going to move those blades to a higher pitch. It's going to bring oil in. And what moves this to a higher pitch position? What increases blade angle on most of these propellers? What's that? It's centrifugal force acting on counterweights and springs. So that's going to, when we bring this forward, when we push our lever forward, it's going to actually pull this follower sleeve back. That's going to close off oil being able to go in the beta tube, and it's going to open a passage where oil can travel back through the beta tube and return to the sump. Okay? And as it does that, the propeller blades are going to go to that coarser pitch position. Okay? When it gets to, as well as it does that, that whole beta tube's now going to move aft, and when it moves aft far enough, it'll bring it back to the point where this port gets covered by the end of the follower sleeve there, and that's what'll stop it from continuing to go to a fully feathered position. Okay? And as it does that, though, what's going to happen to the RPM? If we go to that, we've pushed our prop lever or our power lever forward. In this case, all it's really doing is moving the sleeve and moving, causing the actuator to go, causing the beta tube to move. what's going to happen to the RPM of the prop and the engine as we do that? We're going to a higher blade angle. What happens to RPM? It starts to drop. And the engine, the fuel control governor, not shown here, but the one that provides fuel to the engine, that's going to sense that drop in RPM, and it's going to schedule additional fuel to bring up the power of the engine to drive that propeller back to the speed that we've selected by the condition lever. We haven't even touched the condition lever. It's still in the start and taxi rate. So the blade angle is going to change, but ultimately the speed is not going to change much. It's going to want to stay where it's at. But the blade angle has increased, the engine power has increased, and so our forward thrust is going to increase. And we'll start rolling faster or taxiing faster. But still, again, in that beta range. So here's kind of a bigger picture of that. I guess I got ahead of myself a little bit. We push the power lever forward. Below 95%, however, the following sleeve moved aft, closed off our oil pressure source here. It can't get into the beta tube. Open this slot in the beta tube. Oil can leave the dome out through the beta tube into the sump. And then the propeller piston, which is the whole dome in this case, moves aft. That brings the beta tube with it. The beta tube is attached. It's bolted into the end right here. And as it slides aft, when the blade angle increases to the point that we've selected, this drain pressure port is going to line back up with the end of the follower sleeve here, and that's going to stop it from continuing to go any further higher pitch or even to feather. The reverse of that, when we want to slow down, when we want to bring it back towards an idle position, is that, so now power lever this is what I just explained again, okay? This is the point where now the prop has gone to the higher pitch. There's still oil in the dome. It's not moved all the way aft. You can see there's room for the dome to slide aft. But now this is that position where the beta tube port's now blocked by the follower sleeve. And so we've established a new neutral position at a higher power setting. Okay? So the prop dome isn't going to change much. Oil pressure, there's no oil being returned. There's no oil being able to port out to the prop. It's going to stay where it's at. Okay? And this is where that underspeed governor, as we've slowed the engine down, the underspeed governor on that provides fuel scheduling is going to say the engine slowed down. It's going to add more fuel in order to increase engine power. If we continue to go rearward, we're going to start to go into a reversing position. Sorry, did I mess my power lever move rearward? Yeah, now we move it rearward. Now we want to slow our down. We're not going to reverse yet, but we're bringing our power lever back and we want to reduce the amount of thrust the engine's putting out. So in this case, what happens is as we move that rearward, it's going to push this follower sleeve forward. That's where I got confused there for a second. So we brought our power lever back, we've pulled back. Now the prop is putting out too much power. We want to reduce the amount of power coming from the prop, the amount of thrust. And so as I pull back, I'm coming back towards the idle position. The follower sleeve gets pushed forward. Now, where this return and pressure port was blocked a second ago by the follower sleeve, now it's been ported to our oil pressure. So oil pressure can come in. It comes into the follower sleeve, into the beta tube, travels through the beta tube to the dome, and starts to push the dome back forward. As the dome gets pushed forward, the propeller blades go to a finer blade angle. Okay? And what's going to happen as they go to a finer blade angle? Blade angle's decreased. That's going to cause what? What? It's going to cause an RPM increase. We've gone to a finer pitch, RPM is going to increase. RPM of the propeller, RPM of the engine. So now the fuel control governor on the engine is going to get into what kind of a position, what kind of a condition? It's going to cut back the amount of fuel to the engine in order to maintain that idle RPM setting that we have set by the condition lever. Okay? But so you can see here in the beta range, our power lever is directly controlling the prop blade angle using the prop pitch control unit, the follower sleeve, and the beta tube inside of it. Okay. And so then now the beta tube that was further back, now it's moved forward to the point where it's blocked again. The dome's pushed forward to the point where it's blocked again. And now the prop is locked in a finer pitch, and the fuel control governor, it's the underspeed governor on the engine, is going to schedule the fuel to match our blade angle that we're at now. If we continue to move the throttle lever back, the power lever back, so we've gone from, we started in neutral, we moved our power lever forward, now we've moved it back towards idle, now we're moving it back into the reverse, we're going to continue to happen. It's going to push that follower sleeve even further forward. Okay, even further to the left here. And that reopens that pressure port now to allow oil to go to the dome. Even more pressure goes into the dome. The dome travels even further forward. That moves the dome outward or forward, and the blade angle continues to decrease. Now it's going below zero, and it's going into the negative position. So the face of the blade becomes the back, and the back of the blade becomes the face. And now it's going to start pushing air forward rather than pulling air back, creating a reverse thrust position. And as it goes forward, as that dome moves forward, as we go into reverse, it's going to continue to pull that beta tube to the left, pull it forward, eventually to the point where, again, that port in the beta tube gets blocked by the follower sleeve. And that's going to prevent it from moving further. That's going to put it into the selected prop blade position, in this case being a reverse position. Okay. Now what happens is, what happens when we go to reverse pitch? What's going to happen to the engine RPM? What's it going to start to do again? Now we've gone past zero. We're starting to turn the blades backwards. What's that going to do? You think it's going to increase the RPM? The farther we go back, the more we want to increase. So what's actually happening is we've gone, when we're at zero, that's about the least, when we're at the zero blade position, that's the least amount of resistance we're going to get to that prop spinning. So as we start to go backwards, as we start to bring the blades into the reverse position, there's going to start to be resistance on them again. So the RPM is going to want to drop. The underspeed governor, the engine, which is the fuel control governor, is going to see that RPM drop. It's going to go in what kind of a condition? It's going to go to an underspeed condition. And so it's going to start sending additional fuel to the core of the engine to bring that RPM back up to that idle RPM. And the further we pull back into the reverse range, the further that blade angle goes negative, the more resistance on the prop and the more fuel gets scheduled to go into the engine to provide even more power, additional reverse power. Okay. So you can see here where our power lever, which right now on the ground controls engine power by directly controlling blade angle. And everything else is kind of a passive process after that. We tell it we want to go to this blade angle, and the engine does what it needs to do to run in that condition. Okay? The other mode of operation is our alpha mode. So if we go back to, we're going to neutralize everything out. Everything's been neutralized down here in our pitch control. Now we're pushing the power lever forward. We're into the flight idle position. So let me go back to this real quick. So we're going to move now our power lever. We're going to start going into the flight idle. We're going from ground into the flight idle, just a little bit further forward here. That's going to put us above that 95%. And now we're going to start to enter the alpha range. That's the other mode of operation. And alpha range is going to be anything from flight idle to max. Okay. The other thing that's going to trigger that is the power lever. Sorry, the condition lever is going to get moved from the start and taxi up to the alpha range. So essentially, this lever here on the right, the condition lever, is going to decide, are we in beta mode? Are we in alpha mode? And it's going to change the behavior of the power lever. Okay? So now we've moved our condition lever forward into the flight position, and we end up in alpha mode of operation. So 95 to 100% of RPM. The power lever also is moved a little bit forward into the flight idle position. Okay. And now what happens is the underspeed governor on the engine, the fuel control governor, is going to be essentially taken out of the equation. We have a standard, a normal fuel scheduling governor that's going to take over. And now RPM control is going to be maintained not by the fuel control governor. This is why these were called 100% engine. Basically, the engine's going to ramp up its RPM. It's going to say, I want to go to a high RPM condition. Okay? So it's going to try to maintain that high RPM condition again, but now it's going to do it not by adjusting the amount of fuel to the engine through the underspeed governor. It's going to do it by adjusting the prop governor. And so what happens down here in our prop pitch control is the follower sleeve just gets jammed all the way forward. It gets pushed way forward. And so what that means is, remember, the way we controlled it is, did we block off this port here by sliding the sleeve back? Or did we, go behind it to dump pressure out altogether when we want to go to feather? In this case now, by pushing the follower sleeve all the way forward, it basically just becomes a pass-through where oil pressure coming from the prop governor can just pass through the pitch control and in and out of the prop piston. Okay? And that's done by the cam system here. So when we move that condition lever into the flight idle, we move into the flight position, we move the power lever up into the flight idle position. It's now jammed this, it sent this follower sleeve all the way forward, and it no longer is going to provide any kind of blade angle adjustment for our propeller. It's all going to now be done up here in our prop governor. So the beta tube no longer provides blade angle feedback. Okay, blade angle feedback was used with the beta tube, was used in beta range, hence the term it's called a beta tube. Okay. Now all of our blade angle feedback is going to be done via RPM and its effect on the flyweights in the prop governor and how they move the pilot valve. Okay. So this begins to work just like any other constant speed prop that you've studied in the past. Power lever directly controls the fuel flow to the engine through the fuel control unit. And with a fixed power lever setting, the condition lever is now going to adjust. It's going to provide an input to the speeder springs and the flyweights inside the prop governor. So that condition lever basically acts like a propeller lever now. Okay. Earlier it set our RPM, our low idle RPM. Now it's going to set our RPM as the prop RPM. Okay. And it works like any other constant speed system. So with a fixed condition lever setting, our fixed condition lever is now in that position. The power lever is moved forward, which increases power. That's going to increase fuel flow up to that max, getting our engine up to max RPM. Probably somewhere driving the propeller around 2200 RPM. That additional power is going to cause the propeller to start to overspeed. The RPM is going to increase to the point where it gets into the flyweights inside the propeller governor, gets into that overspeed condition. They get swung out, and they lift the pilot valve, and that's going to port oil. The prop governor now is going to, when these get in an overspeed condition, it's going to port oil pressure down. It's going to take oil pressure that's right here, and it's going to port it. It's going to block this off as we get in an overspeed condition. That's going to allow now oil to come back up through, and when this pilot valve moves to the right, oil can travel through here and back to the case. Okay? And that's going to, the flyweights then are going to drive our prop to increase blade angle. So we're going to essentially, the prop governor, I should say, the prop governor ports oil back to the case, back to the sump, which allows the flyweights and the spring to increase the blade angle. Okay, it reduces the amount of pressure coming from the prop governor pump. RPM now is slowed back to the selected RPM, but the power output's higher. We're going to have more torque because the engine's working harder to spin that prop at that same 2200 roughly RPM speed. That's the governed speed of the propeller, the max speed of the propeller. If we move our prop or our power lever back now, what's going to happen? Fuel flow will decrease. That'll reduce the amount of power the engine's putting out. Remember, we're at a bit higher blade angle. Okay, we drove to a higher blade angle before. Now we're at a higher blade angle. That higher blade angle is going to have more going to have that air resistance on it. So that's going to cause, with less fuel flow, less power coming from the engine, the RPM is going to decrease. That's going to put our prop governor into an underspeed condition. And now it's going to port additional oil. I have a mistake in my slides. I do, and I apologize. I got these two. This line right here got swapped on the two slides, the third line down. This one should cause RPM decrease. The prop governor should port oil out to the propeller to decrease blade angle. Okay? Remember, oil on these makes it go thing. So I have an error in the slides, and I will get that fixed and get that uploaded. The oil gets sent to the prop, so we're going to ignore this line. And that's going to go to a finer blade angle, and then the RPM is going to increase back to the selected RPM, but it's going to be at a reduced power output because there's not as much fuel going to the engine. Okay? What slides are those? 23 and 24. I will get that fixed here shortly. When we're in alpha mode, if there is a failure, we want to be able to feather the propeller. Remember, during normal shutdown, we don't want to feather the propeller. And so during a normal shutdown, the prop is held by oil pressure in that high RPM, low blade angle, fine pitch position, as the engine starts to spin down to a point where the stop locks or the start locks can engage before the oil pressure is released. But when we're in flight, if we have an engine failure, we want to release the oil pressure before those start locks can get back into place. And so that's what our feathering valve is able to do. Okay. So if we're in flight, if we're in essentially alpha mode operation, and we need to feather the propeller, and we want it to go to feather without the start locks engaging, remember, the prop governor's up here at the top. That's supplying our oil pressure, but the prop feathering valve gets pulled. That's going to allow oil to flow out of the dome. Again, our pitch control right now is that sleeve, that beta sleeve is pushed all the way forward. It's not going to do anything. It's as a pass-through port. It's going to go back to the feathering valve, and now oil, instead of pressure, which would be coming from this uncolored line here on the left, now oil can travel out the overflow of the vent back to the case. And so what will happen is the prop blades will be able to they will get below a fine pitch position. They'll go to a higher pitch position, before their RPMs slow down enough that the start locks can re-engage. And so the prop will be able to go to feather rather than being locked in the fine RPM position. So oil's released, sent back to the sump. The centrifugal locks can't engage because the blades are not in that 0 degree position by the time the RPM slows down enough that centrifugal force is no longer pulling them out. If you look at it a little bit bigger, you've got this going on here. Just kind of an overview, you put the whole system together and it looks something like this. Okay, this isn't a given position or anything going on, but we have our, in addition to these, we have our torque sensors, which can also act as a, they are a negative torque sensor, which does a similar function. They are able to activate the feathering valve in the case of an under torque condition. Under torque means the prop could potentially spin way too fast because we got a breeze, a tailwind or some other thing that can suddenly reduce load on the engine. We never want the propeller to drive the engine. We always want the engine to drive the propeller. So if that's the case, what we'll get is a surge in oil pressure that actually can activate the feathering valve by pushing on this big piston inside the feathering valve. It'll push that oil that's caused by a negative torque, will push this valve over and automatically operate the feathering valve in order to feather the prop and put more resistance on it so that it can't go into a negative torque condition. And this also shows just where oil can kind of come in from the lubrication system. We do have a feathering pump there, and we can run that on the ground if the prop blades are in a feathered position. We need to be able to drive them back to fine pitch before we can start the engine. That's what we would use this unfeathering pump for right here. It's an electrically driven oil pump that can be operated when necessary. Okay. There are questions on this stuff. So again, I'll go back. I do apologize for the typos on these two slides. They are reversed. This one should say the prop governor ports oil to increase blade angle should be on this slide to reduce blade angle. Here, this should be the one where prop oil is released from the propeller in order to increase the blade angle and bring the RPM back down.